Okay. Um, so this is part two. So let's talk about enzymes. Okay. So enzymes s- speed up biochemical reactions. Okay. So an enzyme is a protein that acts as a catalyst. So the whole purpose of enzymes in our body is to speed up chemical reactions without being consumed themselves. Okay. So they can speed up chemical reactions thousands and millions, thousands times faster than how these chemicals would normally act. Okay, so enzymes aren't magic. They don't make chemical reactions that normally wouldn't occur. But what they do is speed them up tremendously. Okay, they increase the reaction time by millions on average. Okay. All right, so a couple of definitions: substrate, reactants, products. Okay, substrates. Uh, okay, products. Okay, and then these um, substrates are also reactants. Okay. Okay. Each enzyme fits the shape of a particular substrate. Okay. That is a very important thing. Um, if it doesn't fit the shape of the substrate, then nothing would actually happen. Okay. Um, an enzyme has a really important little site called the active site. The active site is where all the magic occurs. Okay. So the active site has to fit the substrate. The substrate has to fit within the active site for the reaction to occur. So if I change the active site, or if I change the substrate slightly, even slightly, where it no longer fits the active site and no longer works. Okay. Okay. Enzymes form the products of the reaction. Okay. Um, so the enzymes themselves don't actually change. Okay. And so they can be used over and over and over and over again. Okay. So one enzyme can catalyze hundreds of thousands of reactions before being too damaged to continue. Okay. So I said basically earlier that enzymes are not magic, and they're not. Okay, what they do is they lower the energy of activation, and that makes things go faster. Okay, because every chemical molecule has a little bit of energy. Okay, some have, but some have more than others. Okay, so but very few will have enough activation energy to actually trigger this reaction without some type of help. Okay, so imagine that you're on the fourth floor of a building. So you have some amount of energy because you're not on the bottom yet. Okay, and there are two ways to get down. Way number one, I climb up to the fifth floor and I run back down, always in the first floor. Okay, most of you guys, if I ask you guys if you have enough energy to run up a flight of stairs and then run back down, you'll probably say yes. Okay, but if I ask you to go on the fourth floor, run up to the 100th floor, and then run all the way back down, well, most of you guys would not have the energy to do that, and some of you guys would die trying. So, it wouldn't happen, right? One of you guys might be able to get up to the 100th floor and run back down, but not everybody, okay? And definitely not me, okay? So we simply don't have the activation energy to get all the way down, okay? Okay. So hopefully that makes sense. Yes. Okay. So okay, cells control their own chemical reactions. Okay, so what you want to do in terms of the cell is you only want certain chemical reactions occurring at a certain time. Okay, like I do not want my cells to make all the ATP possibly can because that would take up way too much room. Okay, I just want my cells to make enough ATP that I am functional. I'm well off. Okay, I don't want too little ATP, but I don't want too much. Okay, I don't want too much amino acids. I don't want too little amino acids. I want just enough. Okay, and so we have to control our enzymes. Okay, we have to be able to turn the enzymes off. Okay, basically, how we turn the enzymes off are inhibitors of enzymes. Okay, inhibitors turn off enzymes that don't need to be on. Okay, so once there's enough products in the cell, it will be a waste of energy to produce that more of that product because not only does it waste energy because you have too much, it actually takes up space and energy that you can be used for other stuff. Okay, like you don't want like 3 years worth of food in your pantry. That really doesn't help. All right, so like you want to keep some food in your pantry that you can get through the day, maybe the week with, but you don't want like 3 years worth of food in there because that will take up more room that you put other for other stuff. Okay, so what you want to do is limit the amount of X, Y, or Z that you have. Okay. Yeah, and that's what inhibitor. Okay. So substrate molecules usually bind to the active sites of enzymes. But what if another molecule actually prevents it? And that is competitive or non-competitive inhibition. The answer to that is that enzyme becomes less active. Okay. So make sure you understand the difference between competitive inhibitor and non-competitive inhibitor, because that will be on a test. Okay. Okay. I'm gonna come back to this one. This one's easier to understand. Competitive inhibitors compete for the same active site. Okay, that's what it means to be competitive. They actually compete for the same active site. Okay. Molecules that bind to the enzyme right at the active site keep the substrate and the enzyme from binding together. Okay. If I fit into that hole, then the substrate can't stay there. Okay. If I fit in that hole very perfectly, I can stay there for a while and I would inhibit the enzyme from working. Okay. Okay. Non-competitive inhibitors do not bind to the shape of the active site. They bind to a location somewhere away from the active site. But the binding of that changes the shape of the active site, and therefore the substrate and enzyme can't bind together anymore. Okay. Okay. Either way, the active site is no longer available for the substrate. Okay. Okay. Enzymes are only active within a range of temperatures and a range of pHs at which their activity is the greatest. Okay. Our enzymes are designed to function at 37 degrees Celsius. They do not function at 4 degrees. They do not function at 55. They only function really at exactly our body temperature, which is 37. Okay. But in places where the temperature is 77 degrees Celsius, like the hot springs, there are things living there that are designed to live at 77. So at 77, they're perfectly happy and they're perfectly fine, and their enzymes work perfectly well. You take that enzyme from that bacteria and you put it at room temperature, and it doesn't work. Okay. The same is true of salt concentrations and pH. Okay. You add enough salt, your enzyme will no longer work. You change it, you make it acidic or more basic, the enzyme will no longer work. Okay. So hopefully the answer is 78 degrees. So like at 78 degrees, you'll see that there's a sharp decline in enzyme activity, which means to stop working. Okay. All right, we'll pick this up on part 3.